You know, one of the themes at Computex that I saw was so many different power supply manufacturers and brands kind of putting their own unique flavor or sauce, if you will, to try and keep cables from melting. And here's the thing, I've seen so many comments, people that are like, it doesn't matter, I'm not running a 5090 or a 4090, I'm not gonna melt a cable. Well, tell that to the 9070 XT owners that are running 12 volt high power on like the Nitro Plus, and I think there's another model that have also been melting cables at 350 watts. So, today we're gonna talk about the Asus ROG Equalizer. It's a completely dumb intelligent cable, I guess. We'll talk about what makes this one unique, and we're gonna test it today by, well, cutting some cables. If you're serious about your aim, your mouse actually matters more than people think. And this is Be Quiet's new Dark Perk gaming mouse. Now what I like is that they don't do the usual one shape fits nobody approach. You've got two options, the Sim, which is a classical symmetrical design, and the Ergo, if you want something that actually fits your hand for longer sessions. It's also super lightweight, which makes a bigger difference than people realize, and less fatigue, easier micro adjustments, and just better overall control. And inside you get the PixArt PAW3950 sensor, up to 32,000 DPI, and 8,000 Hertz polling. So yeah, this is top tier tracking and no weird acceleration, no spin outs, and just exactly what you expect your mouse to do. And the clicks feel really nice too. These are optical Omron switches, so they're fast, consistent, and a little softer than the typical click, which is great for long sessions. And then the part that people overlook, it's 100% PTFE skates with rounded edges, which means this thing glides smooth, predictable, and with no drag. Oh, and with up to 110 hours of battery life, so you're not constantly plugging it in. So if you're trying to get every little advantage you can in competitive gaming, this is one of those upgrades you'll actually notice. So check out the Be Quiet Dark Perk mouse in the link in the description below. So this is the ROG Equalizer. It comes included with the Thor, and I think there's another power supply they have that has it with it. That's why it's got this kind of a data plug, if you will. I think it's just a voltage sensing or something. Anyway, but they sell these individually. So I've got one, and I've also got one here that's like ripped open so you can see what's different about it. So here's the thing. What is causing these cables to fail? I had this conversation with their engineers while I was at Computex, and it's kind of like a consensus of very high power needs in a very loose spec, if you will. And what I mean by loose is they still firmly believe it is a cable quality issue, not necessarily a power supply issue or a graphics card issue. And that appears to be somewhat evident by the fact that lower powered cards are also melting the cable, not just 5090s and 4090s, although those are more obvious and more prevalent because they are the highest wattage cards that are out there. But this is just an example of a regular dumb cable, right? So the 16 wires on here, 6 ground, 6 12 volt, and 4 cents, up to 4 cents, depending on the spec of the cable. That's why they call it a 16 pin, even though sometimes there'll only be 14 pins present because the 600 watt cables will only have a ground and then they'll bridge the 1 pin that's needed to tell it's 600 watts. Anyway, what was kind of the consensus of where the inconsistencies are is going to be in the pin quality. We've talked about this 1,000 times. You've got dimple versus dual spring versus force spring, which is the different types of mechanism of mechanical connection between the pin that sticks out of the graphics card and the female end of the pin, which slides onto that. You've got different pin materials. You've got some companies using cheap aluminum pins. You've got other companies using like brass or other soft metals with tin on there. There's obviously how many times it's been cycled or mated. There's the possibility of wearing down that tin material as you overmate and connect. So I say overmate or overconnect too many times because we have a 5090 that's been cycled probably a few hundred times. Even a brand new cable, which used to fit really tight in that card, is loose and wiggly because I'm fairly certain now we have shaved plastic material away and we have shaved pin material away on the male pin. So that card is probably primed to fail, right? So that's why I'm just like letting it ride or die. It's gonna die. There's no doubt about it because of what that card has been through already. It's just a matter of time. But what ROG has tried to come up with is a way to make sure that the amount of amps per pin is uniform at the GPU at all times. Now, I'm a little concerned by how uneven the pins look. Actually, they're super even on the GPU side, which is this side, and super uneven on the power supply side. But that could be a moot point. We kind of showed that with the Corsair cable that it really kind of didn't matter as long as enough of the pin receptacle is making good mating contact and to carry the full 9.2 to 9.4 amps it's supposed to carry, it doesn't matter. Adding more contact area isn't gonna help, until it becomes less contact area, which means now other pins are having to pick up the load because there's poor contact between some of the pins. And that's what leads to the melting situation. So what they came up with here is this guy right here, which essentially is adding a bus to both the 12 volt and the ground independently so that it's always even leading into the GPU. It's not monitoring amps. It's not going to like automatically shut down your graphics card or cut power to it or anything like that. What theoretically could happen here is it would melt here before the plug, saving your graphics card. Here's one that's busted open. So obviously the insulation material between the 12 volt and the ground is missing. Otherwise you would not bridge 12 volt and ground together. That's called a short. But you can see right here, the cables are independent up to this point, and then they all meet up right here, giving even distribution to the graphics card. Same thing on the ground side. Theoretically, that's supposed to redistribute the power evenly on the graphics card side, alleviating any sort of melting issue on the GPU end. Now, they said they've been running these in their lab, testing them with, I think they said 3 wires cut on the 12 volt side, and have yet to see a failure, including melting here. Now, the cables here are not just the same cable. Their documentation shows that each one of their cables are rated to 17 amps per wire, which is already way above the spec of the 9.2 to 9.4 amps. A 5090 at full load pulls about 56 or so amps. 17 times 3 is not 56. So that has to mean that when they cut it, and they were running it, I think they said for 18 days, long time, like at full load, for a long period of time, without seeing anything melt. That means that each one of these cables were still being run over their rated 17 amps without it melting. So the idea here is that it's a very beefy cable design, very beefy insulation, where they said also too, the max temperature they were seeing was something like 76 C per wire at that like crazy rating, where the cables that were failing were hitting like 146 C and above. So we're gonna test that today. So first things first, I want to see how even the power going into the Astral is, and that's why the Astral's here. It's the only card I have that has per pin monitoring on board, so we can see that figure. I have it hooked up to my PMD just because that's what this test bench has on it. And then what we'll do is we will one at a time cut the wires and start to monitor what's happening. I guess I should also probably get my thermal camera, huh? So I'm gonna use Still Nomad to get the GPU under full load. It's the best raster test for doing full load on any GPU. I have it locked in Explorer mode, so the scene's not moving. Well, the camera angle's not moving, the scene is progressing. But we wanna look at the pin distribution right here. It's funny how pin 1 is still lower than the rest, which has to mean at that point, it is a uneven connection type on the GPU itself. That could be a myriad of things. Hey, I used a big word. I think I used it correctly. Comment down below if I did. Anyway, here's my clamp meter. What I want to show is the huge distribution, the discrepancy. Ooh, one of them just hit 9.2 right there. 9.1, 9.2. This is normal. As the graphics card gets hotter, the amp draw will get higher. So it's kind of interesting that we have 2 pins right now that are maxing out, and then we have 1 pin that's really low. But I want to now test with our clamp meter, which has its own, even though it's a fluke and it's calibrated, it still has its own inaccuracies. It's just sensing the magnetic field of the current going through to give us a measurement. So 1 wire here so far, and I don't know which pin it is, that's showing 9.4, 9.5, 9.6, 9.5. Next wire, 9.9. Next wire, 9.2, 9.3, 9.4. Next wire here, 9.3. So what I'm looking for here is any one of these super low versus the rest to try and account for that pin 1. Pretty sure that's obviously going to be on the GPU side because it's before the bus. I clearly can't measure it after the bus, there's not enough room there. And then the last one here is 9.1, 9.2. Total amp draw through there, about 52 amps, for 51.5. But what I'm gonna do is while it's actually running, but anyway, here's our cable temperature running right around 40 degrees. So if what they said is true, I should be able to cut one of these in real time and not have the graphics card cut out. The card is intelligent enough to know if it loses 1 cable, right? Any other graphics card typically has a bus on the connector side, on the card. So that's where it smooths itself back out, right? Because the Astral has per pin monitoring, it has its own circuitry for each pin. And if one of those pins drops out, then it will turn off the card because it knows something bad happened. Other graphics cards don't. They just unify all the 12 volt and all the ground together at the plug end, and then just off it goes. So then if one of those cables pulls out or the pin pulls out, the graphics card doesn't know, and then that tends to lead to the problem. So I think that's one of the reasons why we haven't seen any Astral cards, as far as I've seen, melt, because they're more intelligent than that. Mine did because I was using an adapter like this, right? And what happened is right as it started to fail, it started to transfer just a slight amount of plastic residue to the pin is when it shut itself off, because that one pin disconnected itself. Although I still had to replace the connector, it didn't lead to a catastrophic failure. But a failure nonetheless, it still required me to replace the connector. If this equalizer is doing its job, it is still going to give equal distribution to the GPU, but the wires down here are going to start carrying much more of the load. All right. And look at the pins.
Didn't even change.
Nope, they didn't, because they're doing their job. And I need to be careful with this end. This end's hot. And technically so's that end, because it's being redistributed back the other way. So both ends are hot. Okay, I needed wire nuts. Why didn't I think about this?
Lick your finger and then do it.
No! You can see there, still 7.8, right? Still that one lower there. So they're all technically within spec. So now this one, look at that. Now it's pulling 11.2 amps, 11.4, 10.9, 11, 10.8. Now remember, the documentation said their per pin spec is 17 amps. Well, you know what they say. This seems like a great idea, doesn't it? Nothing changed over here. Now it's up to about 40 degrees. 41 degrees. Individual amps on the wires now, 13.4, 13.7, 13.2, 3, 14.1, 0.2. So one of these is carrying more than the others, but then as a total, still pulling the whole 50, just under 52 amps. Well, I say I matched their test and I cut one more. Now, here's the thing. If this is happening to your system, and say you're having pin drop out like this, you're not gonna know. There's no way for you to know. Individually, oh, we're right at spec, 17.8, 18.3, 18.2. Okay, they went up 6 degrees so far at 46.2, 46.3. So what I think we need to do now is we just need to cut and just let it run. And for a little while, anyway, I don't know, maybe a half hour, something. I just want to see where the temperatures kind of max out. You see we have one pin complaining it was at 9.2, oh no. Meanwhile, the equalizer's like, what the frick? If this was any regular cable, obviously the Astral would have immediately shut off when I cut the first cable because of pin sense. Any other graphics card, ooh, they're getting warmish now. Any other graphics card would probably have kept working because again, it's unified, but at the GPU side, which is where the heat would be building up most. Temperatures are now at 50 degrees, 51. So what happens when the cables melt is they get this thermal runaway, which does not seem to be running away. It seems to be more or less like a slow wheelchair escape. All right, we'll just let it go for a while. It is currently 12:36 p.m. We'll come back and check it at 1 p.m. All right, so it's currently 1:01 p.m. right now. So it's been running for about the 30 minutes that I said. The hottest any of the pins have gotten, not hottest, the highest amps any pin got was pin 1 and pin 3 at 9.4 amps. Okay, so we still only have 3 working wires right here. Temperature, 51 degrees. It went up within a couple of minutes to that and then it stopped. Now I have to correct myself. They ran it for 240 hours or 10 days with 2 wires. So I'm not about to go to that level, but that's pretty impressive. Now, one of the reasons why is they're using a solid copper core. So it's like it looks like almost like a giant torsion cable like you would find in a bridge, just really small. That's solid copper, twisted, and then they have a tinned material around that, and then they have the insulation wire right here. Just the construction of that wire is why they're claiming 17 amps. Now, they do have what they're calling double protection coming soon. This isn't an ad or anything like that. It's just my biggest concern was like, okay, the end user would never know this is happening, right? Unless you have this end plugged into a power supply, which is not sensing amps. This is just about voltage smoothing to the graphics card or the CPU, depending on which you tell it to prioritize, because you can have these transient spikes and dips and stuff. It's designed to smooth out voltage to the graphics card or the CPU, depending on where you prioritize it in the power supply settings. But they have something coming soon, according to their website. I've not had communication with them about any of this stuff, we're just learning about it ourselves, but it's called Power Detector Plus. So basically it takes the physical protection, which is what this is providing, and then couples it with a pin sense on the power supply end. So that makes it universal. Whereas, because this has pin amp sensing built into the graphics card, which is why we're displaying it right here. Every single time I mention the Astral has this, people ask me like, how are you getting that to show up? That's just showing up because Hardware Info 64 scans all sensors in the system, including the graphics card. It has its own. But I guess some of the newer power supplies that are coming out are going to have that feature built in to the power supply side, which is fine because the power is the same on both ends, right? So instead of having a graphics card that communicates to the system saying, hey, what the pin amps are, the power supply will be doing it. So theoretically, by coupling this cable with that, gives you basically a physical protection here at the graphics card end, and then the intelligent side of the power supply end saying, whoa, we're out of balance here, warn the user. Because my concern with this, and I said this to the engineers, is like, if somebody just buys this cable, which you can buy individually and hook up to any power supply, you just won't have this end plugged into anything if it's not a Strix or an ROG power supply, a Strix or a Thor power supply. I said, the end user will never know this is happening. Now, theoretically, by them running 10 days at full load of 2 wires and having it not fail, it wouldn't matter to the end user, but I'm not okay with that. I'm like, the end user should know something failed along the way. And having the power supply end be what's sensing the amps on this end before the bridge can then be able to tell, like if something disconnected from right here, right? Or cut along the way like I just did, we just showed you, right? The amps per wire go up. So the power supply would know like, whoa, this wire is at 17.5, 18 amps. Notify the user. And then that's built into GPU tweak. I think that's kind of smart. Like everyone's looking at this whole like intelligent monitoring, auto shutdowns and such, but this is the only solution so far that is implementing a physical solution on top of an intelligent software solution. So this might be the ultimate insurance. And I just kept saying this to all the brands because I talked to Thermal Grizzly with their new WireView 2 Pro, talked to Cooler Master, obviously, with their GPU Shield, obviously talked to ROG about the Equalizer. The theme for power supplies at Computex was how to protect the end user from a poor design. And it's crazy how everyone's having to come up with these different solutions, but this one's kind of neat because as we just demonstrated, it provides a physical solution that protects the graphics card. I would much rather have it fail here than on the GPU side. But if it gets to the point where it's failing here and you don't know and it's starting to melt, that could in itself become potential fire hazard, especially if you're not aware of it. That's why having the GPU Detect Plus or whatever it's called is kind of a nice feature to have. Now I have no doubt somebody has already posted in the comments section, Jay, one of the cables has burned. Here's the weird thing about that. One, if you look at the picture, and I already said this, I think in the video somewhere. By the time you guys see these videos, sometimes they're up to a week old. This video is like, by the time you see it, is already a week old. So obviously before it went live, the picture of one of these cables having actually burned has dropped. No information, no graphics card, no system information, nothing. It's just basically an image and a chat log. But obviously there have to be some sort of analysis on it. But I pointed out that they always seem to start burning with the corner pins first on the 12 volt every single time. If you look at the cables, all the ones that have ever burned, you'll notice the hottest part was always on the outside, and that's clearly where it started and then kind of starts melting across from there. I don't know if that's literally a smoking gun, literally. But anyway, we're still gonna obviously put out this video because it's an interesting tech, and the fact that it burned on this end of the equalizer means it has to be something not only related potentially with the plug, but the graphics card too. It's so funny too, because after meeting with the Asus engineers, they were pretty confident that they have like solved the problem. No, these are still band-aids on top of a bigger problem, which is a terrible spec that NVIDIA greenlit. Because they were part of PCIe SIG, and they're the ones that were given all the advice and all the direction on how it should be, and there's more ways NVIDIA is fucking up our lives. Let's get back to the conclusion. But yeah, we saw that, obviously, so don't know what that's all about, but I still wouldn't call this a bad design. It's just clearly whatever is causing the problems is kind of bigger than any of the solutions that exist so far. Because the solution really is, it needs a new design. I'm curious as to if we get our hands on one of those power supplies, if hardware info would be able to integrate that sensor. Potentially even ADA64 would be able to integrate that sensor, which means you could then have other warnings pop up if you didn't want to have the third-party like GPU tweak software running. ADA64 is able to see all of the pins as well. That's why on my system at home with my sensor panel, I can see digital pin readouts and a gauge, so I know what my pin distribution looks like. Theoretically, if the GPU has that as well, and that USB plug from the GPU is plugged into the motherboard, hardware info should also be able to see that, theoretically. Gotta get my hands on one to see if that works or not. All right, there you go. I don't know, part of me thought the moment I cut one of the cables, it was gonna turn off, which is how the Astral would normally work, but not normal graphics cards. We talked about that. That's unified bridge at the GPU, which is where the source of the heat would be, which is why it fails that way. And as you can see, this is obviously helping. So not an ad for them, not a sponsored video or anything, just something I got my hands on and I went, I want to test it. Kind of sucks I had to destroy one of the cables to test it, but we have another one. That's okay. All right, guys, thanks for watching. Oh, and if you're curious, I don't want to move it. It's been running at almost 650 watts this entire time because efficiency loss. To get 600 watts of the graphics card, it has to pull more than that through the power supply because of efficiency loss along the way. So 600 watt power or graphics cards really are pulling more than 620 watts on the norm. That's why we have the problems we have today. If next gen doesn't include two plugs for every single 80 and 90 tier, then clearly it's planned destruction. So, all right guys, thanks for watching. Let us know about any other devices you want us to test and potentially get destructive with. All right guys, we'll see you in the next one.